Find the relative heating effects, that is the ratio of RMS values of two current waves of equal peak value. One of them is sinusoidal and the other is rectangular. So here I have a sinusoidal current waveform, and suppose this peak value is A. Here I have a rectangular waveform, and again this peak value is A. So if this is A, then this is minus A, and here also this is minus A. We have to find the ratio of the two RMS values. First, let us calculate the RMS value of this rectangular waveform. To calculate RMS value, what do we have to do? First, we have to square this function. So if this is A, okay, then A square will be somewhere here. Okay, so here this is A, so A square will be here. So this is A square, and minus A squared will also be A square. So this is the square of this function. So this is the square of this function. This is A squared. Okay, now what will be the average of this function? Since this is constant, the average will be this value itself. Okay, so therefore average squared value will be equal to A squared, and therefore root mean squared or root of average squared value, RMS value, will be equal to square root of A square, that is A. So this is the RMS value of this function. Now here this function is sinusoidal. Let me write it as sine omega t multiplied by A, where omega should be equal to 2 pi by t, that is the angular frequency, where t is this time period. Now to calculate the RMS value of this function, I will first square this function, which will be A squared sine squared omega t. Then I will integrate it from 0 to capital T over a complete cycle, and so this is the total area under the square of this function over a complete cycle. If I divide this by capital T, then this will be the average of the squared value. Okay, dt I missed here. Yeah, so this is the average squared value. Average squared value. Now let us find out how much is this. So this will be equal to A square. I can write outside the integration. Then sine square omega t can be written as 1 minus cosine 2 omega t, and divided by 2 dt. Okay, this is integrated from 0 to capital T, and then whole divided by capital T. Now if you carry out this integration, you have A squared by t here. Integration of 1 is t, and integration of cosine is sine 2 omega t divided by 2 omega minus here, okay? And then the limits of integration are 0 and capital T, and I have a half here. Let me write that half outside. Okay, so if you put these two limits, this second term will give you 0, and this will be equal to a square by 2t into capital T from here. So this will be equal to a square by 2. Okay, so the RMS value will be square root of this quantity, average squared value. So that will be a by root 2. Okay, so therefore the ratio of these two RMS values, ratio of the two RMS values will be equal to a by root 2 whole divided by this a, which is 1 by root 2, and that is the answer. Okay,